this morning.
Barely going strong. Good morning, all. Lovely to see all these faces. I know a couple of them, which is pretty great. And nice to meet you in person. Thank you for attending this morning. And there we go. I wanted to know where that is. The funny thing is, there was beers for peers today, or last night, should I say. I was just wondering, what's the turnout going to be like? Even with a good turnout, which is a good turnout, you go to sleep and you wake up and your Garmin tells you that you've had a pathetic sleep. So I've got a sleep score which is useless. But there we go. That's technology influencing even your sleep these days. Right. Who am I? There we go. My name is Stanford from 28 East. We're a geospatial company. And we are also a Google Maps partner, but we're not going to be talking about that. We're going to be talking about some of the analysis that we are able to perform geospatially in order to understand what is going on in the F&O markets. Having said that, there are some important distinctions to make and in some important understandings of the data before understanding the analysis. So that's what essentially I'm going to be touching on, is understanding what data we have analyzed and as a result, what are the results. But I can't go on without actually just touching on some of the interesting technologies, Google technologies out there that we can rely on, make use of in the markets and get ISPs to make use of as well. So immersive maps. And I love this one. We had a bit of our developers doing some immersive mapping, and here comes 28 East in the aeroplane down to Cape Town. It's the wrong route, I realize that, but anyway, we can't all be, we don't know the flight paths down into Cape Town International Airport. But anyway, that's us, and that is some of the immersive mapping that we can make use of as solutions for internet service providers. I wish there was some dramatic music for this. Wouldn't that be nice? But there isn't. And in addition to, okay, it looks like we're going to have to get to the end of the little video before I can go to the next one. So I think you get it. The next one is optimization, route optimization, useful for internet service providers, optimizing optimizing routes for technical teams, for example, distributing and getting technical teams to and from sites, operational sites. That is a Google optimization tool that we can make use of. Advanced markers as well. Just interesting that at a particular point, we can actually introduce some customized labeling. There is also, from a Google perspective, something called, a big focus on environmental. And this is one of the little, we call it the Solar API, which is probably quite useful for internet service providers, understanding, power is a driver, and the understanding of solar potential for particular sites is useful for service providers, and an API that can be relied on also from Google. But this is where we really want to focus our attention. And it's the ISPA Insights. Right, finally I've got a map and I feel a whole lot more comfortable as well. Ant has approached 28 East and they said, well, listen, you've got geospatial experience. Let's see what we can do with the data that we have access to. So what is the data that we have access to? Access, I use that quite loosely, but because because we are an integrator of F&O network data, in order to allow a service provider to query an address and find out what service is available at that address or at that point on the map, a pin on the map, we have access to the F&O data. Not all of the data, it is only client or data that that the well, should we say, data that are part of the underlying service that we offer to ISPs. So the ISPs will sell on a service provider, on a provider. We have that data. So service provider can say, oh, okay, what is the address? And hence we do a geospatial query behind the scenes and identify whether there is a service in a particular area. By aggregating that data, we then are able to make use of that data source to do this analysis. So what we have for the spatial analysis, we have the footprints in polygons, lines as well. And then to make sense of the footprints, I mean, we could just map out the footprints and look where there would be colorful spots, as you can see on the map. But that really doesn't make sense because that's just a footprint, and so what? What does that actually represent? Or how do you take that analysis further? You take that analysis further, the answer is by introducing data such as, what's ubiquitous in South Africa as far as data goes that we could make use of? And he's miming the word right here. Thanks, Ant. Census data. So we match, well, no, we don't match at all. We mix, we layer. We layer the census data, which was over the entire South African extent, and we overlay the fiber network operator's footprint on top of the census data and extract further information, which is interesting. Well, should we say, the interesting part of that is we, in terms of analyzing or extracting out as much information as possible, we've made use of the areas of the census boundaries. Okay, so the census boundaries are enumeration areas. They roll up into larger and larger areas, all quite nicely nested, so it's quite nice and neat data. And we have decided to use something called the subplace, which is essentially the suburbs, and it's most people understand a suburb. Like, okay, I'm in Irene at the offices, and I know more or less the extent of Irene, and you kind of like got a concept of understanding, spatial understanding. So we used the subplace and the area of the subplace, and we intersected the footprints of the fiber network operator with the area of the subplace. And that's the initial basis of the analysis that we did. And that introduces some interesting insights, but there's a cautionary tale there as well. And the cautionary tale is, you could probably spot a couple of the cautionary tales in this diagram that you see, well, actually in the map that you see in front of you. So, the map that we have in front of us, first of all, there we go, 37.4% of South Africa is covered by fiber based on area. Okay, based on area, that's an important thing. It is not 37.4% of South Africa is covered in terms of population densities or anything like that. Okay, so it's not on the population, though there can be some interpretation because we've used the census numbers in that. Okay, so what do we have here? No, actually maybe I'll take a step back, or should I take a step forward? Let's just change that view. Okay, so I think everyone would probably instinctually know that areas like the Western Cape and Gauteng have a large number of operators in that area, in that space, and it is true. Gauteng, 86.13% of the physical area is covered or intersected by a network, by a footprint, by some sort of provider. In this particular diagram, I'm going to now just dive into a little bit more of the details. On the right, can you actually, you can maybe just see that. The darker colors, 7 providers, right at the bottom of the legend. You can see Central Gauteng, Joburg, Pretoria area, at least covered with at least 4 provider options or choices, I suppose. And then there is a cautionary tale there, so I'm going to just remember that. So Gauteng, 86.13, and we go to where we are at the moment, Western Cape. Does that look kind of like, if you had to see that, the map there, you can see the dark colors representing high numbers of providers deep in the Western Cape. On the borders on the Eastern Cape there as well, seems to be quite a lot of activity, 3 providers. Does that kind of resonate with expectations? I would imagine so. Right, from well-serviced areas to very unserviced areas. And unfortunately, we've got little Eastern Cape sitting there with not too much options as far as providers go. So ISPA have, here we can see one, they say, oh, goodness gracious, now what on earth is going on here? Because here we've got, to the west of Klerksdorp is that little dot on the east side there. On the west side, no, sorry, it's right in the center of this particular map. What on earth is going here? Here we have a rural area in Klerksdorp with a massive number of providers, and this is where the cautionary tale comes in. No, there's not 7 providers, or at least 4 providers in this rural area. There's a combination of data issues that we get to that is unfortunate, gives you just a bit of a skewed picture. In fact, in this case, a very skewed picture, where the combination of the large areas of the census data overlapped with the network operators introduced a display back or a result of an analysis that is incorrect. And that is due to, in part, the census data polygons, and in part to the fiber network operators' data. We don't clean the data, we don't manipulate the data, we receive that data in, I'd say 9 times out of 10, 8 times out of 10 in the KML file format, and we are overlapping those KML files. Now, KML files is it's a blessing and a curse, I've got to be honest. It's a blessing in that they are ubiquitous. It's used in this particular industry a lot. However, it's really just a display. There's no spatial topology built into it. That's a big geospatial word, which helps improve the accuracy of the data. So we're overlapping many layers or KML files on top of the spatial data, and we've got what we call these slivers, we've got these overshoots, we've got these undershoots that presents itself in the data. So in the middle of Klerksdorp there are footprints of at least 4 operators, but because those little boundaries creep into the urban areas, or at least that very large rural area, it then transfers that data or that understanding into the large rural polygon, census polygon. So, cautionary notes. You can't take these maps as is, and this is just a little bit of the more detailed example. It might be a little bit of a messy slide, but it is saying that there are cases in points where we're overlapping the footprint data from the FNOs, and we get 63 overlapping instances of the data. Crazy. That's a whole lot of another policy discussion. It is a data issue, and it's probably an item of discussion that ISPA would have to address, which I'm looking forward to hearing about. So just as an aggregator of the data, this is what 28 East are involved in. What do we do? What is the value proposition of using 28 East in order to do a feasibility query at an address, at a point on the map? Is behind the scenes, our little data warriors are requesting, receiving KML files, KML files is great because it's ubiquitous, as I said, but whew, I was hearing horror stories even last night about using KMLs in network management and understanding straight line networks, and if you don't get it right, you can be kilometers away from your town, village, or address, and those designers who are unfamiliar with scale can get it horribly wrong, and we do see that. But 28 East do not edit that. We use it as is. CSV is points and polygons, or points shape files, which is at least at a file format, and it's a geospatial file format. It's also a little bit old these days, but there is something called topology, which helps to define logic built into the spatial feature. We love those geodatabases as well. We've actually even taken images, snapshots, and lines drawn on snapshots. I mean, lines hand-drawn onto images, and we've had to use that as a data source. Can you imagine the amounts of error and inaccuracies that we introduce into the F&O footprint data, if you wish, and how that is, the repercussion of that comes through in the analysis. As we go forward, I think there's this tendency to make use of API access to spatial data, and we will see probably more of that. Really, and that is, beautifully, my little story. And here's my little chappie who has a question for me. Do you know him? Have you seen him? No? Yes? Where do you know him from? Well, maybe you would have, but he certainly is a train spotter, and that's his train spotting face, and I thought it was a brilliant train spotting face. And that was my closing slide, and that was my question slide. So, over to you. Any questions? I actually can hear a cricket in the corner. I really can. Okay, I've got a question. Can I have a question? My question to the audience, and Esper as well, is, so what else could we do with the data? Right. And that's the question I'd love to hear from you guys. It's awesome that you brought that one up. The additional work we would love to see is the fact that the footprints change almost weekly. So what you see here is a snapshot in time, and happens to be in November last year, but that changes, and we know that every week there's a weekly update, small as it is, but I would love to see that mapping as an ongoing process and seeing or monitoring the change in the footprint penetration into, well, rural areas in particular, but I'd love to see that happen. So, and that can happen. So that's one of the nice questions that I would that I have now addressed, and hopefully satisfied your query as well. Anything else?
Hi, there you go. Okay, Graham here from the internet. I had a question which you kind of answered already about, I mean, looking particularly at the national map, there was a lot of rural areas that showed a provider, and I know that there's no infrastructure in those areas. So, I mean, you're mapping it onto census areas. That's principally why it's showing up. Is that what you're saying? I mean, in the Eastern Cape, for example, I mean, there's fibre in the metros. There is no fibre beyond about 20 kilometres out of the metros. Mm-hmm. So you've got like a 50-kilometre radius showing up there. Is that purely the census boundaries, or?
No. That is actually a very good point, is that we mapped what analysis was what 28 East has access to, and it was open fibre only. So there may be closed fibre routes in there as well, but we only mapped what we have and open fibre. So it might be that we don't have access to that footprint, and hence we can't map it.
So what I'm suggesting is that what you're showing there is not real. And I suspect that some of the data you have has aspirational coverage rather than real coverage.
Yeah.
And I think maybe as an ESPA discussion, what is the definition of coverage? Because, I mean, I've seen some of the maps that some of the FNOs put on their websites,
Sure.
which includes lots of aspirational coverage, lots of like blankets an entire an entire district as having coverage when they actually only have a pop in town and they can do it 5 kilometers around the pop in town.
Yeah.
So I think that's the one concern about kind of just looking at the data and going, lots of people have got coverage already, and I think the reality is a lot less.
Yeah.
The other thing that I noticed about the data was that you showed a lot of places where people have 7 options, and I was wondering how you got to that. Is that an individual at a specific location has 7 options, or are there just 7 options that are present in that polygon?
Yeah, exactly. It's your point 2 there, or your latter point, is if we had a polygon and there was an operator on the east side, west side, and a little intersect, so a tiny little sliver of intersects, we count that as operator 1, operator 2, operator 3. So that's how we got to that 7, yes. And that's how we counted it. But what an addition to that is that we can't actually say that operator 2 at the top on the northern is actually correctly positioned. So it might be more north or might be more south, and we don't have any control over that particular line. But it had to be counted because it is there in our footprint data set.
Yeah, I mean, I think practically the reality of what's on the ground is that I don't know of too many places where there's more than 2 options realistically for home users.
Right.
And then obviously there's the distinction between home services and business services, which also need to kind of be looked at separately, because you certainly can't go to one of the FTTB ISPs and go, please plug in my house, because they might laugh at you, or they might just send you a quote that you're going to fall over. And so it's a good starting point. I think that's taking that data wider and potentially like putting it in front of policymakers and things, it's a bit premature, because it creates an impression that we are a lot further along than I think we are in reality.
Yeah, and I think, well, exactly that, but I also don't want to throw out the baby with the water. So I think you're right, it is a starting point, and it's been acknowledged as a starting point. And by addressing the complications of that data, if you address those complications, you kind of realize with circumspect or with caution that you address that image as is. Thanks for those comments, On switch, the on switch. Yeah. Oh, here we go.
Good morning, William Stuckey, independent consultant. I have a very similar question. What do you define as coverage? If there's a piece of fiber here, whether it's backhaul fiber or whatever, how do you define that there is coverage here or there or not there?
We define it by what the KML is telling us. So the KML from the fiber network operator is what we've mapped, and if it is on the left-hand side of the street, that is our definition of their footprint.
So it's their data.
It's their
They
data.
are claiming that they have coverage.
We do not touch their data. We do not touch it. We do not modify it. We do not add it into a geodatabase and introduce ideas of topology where there shouldn't be overlaps, there shouldn't be slivers, there shouldn't be overshoots in the data, undershoots in the data, which all contributes to spurious data sets. So it is exclusively what we get from the fiber network operator.
Okay.
Yeah.
So then Graham's point of aspirational maps may well be the case.
Absolutely.
Okay,
Yep.
thank you.
Point taken. Come, Mark.
saying, so if you're, I mean, I'm an F&O, so on the route, what you're not depicting is the accessibility to that fiber. And that's probably what your point is. So if it's an NLD route, or these are not accessible to anything that's going past that until it reaches a town or somewhere it can spur off. So that overlapping is what's happening.
Thanks, Mark.
Sort of just tying together some of the questions here. There's F&Os in the room. What advice would you give them about how they should provide you with data to serve your customers better, which is ultimately their customers?
Yeah.
What should that data look like?
Yeah. That's a good one and a tricky one, because I don't want to put my foot in it. But as I said, those KMLs are ubiquitous. They're easy to use. They come from all the F&Os. And I'm from a geospatial background. And I believe that an ideal approach would be to have a geodatabase. So it's a database that understands. It sounds a bit conceptually warped, but understands that I'm on the left-hand side of the road, I'm on the right-hand side of the road, I'm overlapping or I'm snapping to a particular line segment, and there is something called topology that is built into the data repository, into the database. So that would be my my option number one for any ISP to actually make use of geospatial databases to capture the network footprint, and which in turn allows for the combination, or at least the addition or aggregation, should we say, aggregation of the network operator's data into a single data repository that has these rules built into it. And we can see that we don't have all these KMLs sitting on top of each other, all higgly-piggly, as spaghetti or as overlaps, and we can trim that spaghetti mess out and have a single line. Single line represents maybe 2 or 3 operators as an attribute to that line. So that would be my great ambition for any F&O, is to make use of geospatial concepts such as a topologically correct database. Thanks for that.
Hey, Joe from Atomic.
Hi, Joe.
Touching on that point about 7 coverage or 7 options in one area, so can you differentiate between FTTH and FTTB, the sort of easy option to get access to a home versus the long formal quote process?
No, answer is no.
Okay. Because what I'm interested in is, of the FTTH areas, what percentage have more than one option?
Yeah, okay, so that would be a continuation of the analysis, which we haven't actually done. So we aggregated all together, B and H, and that could be an extension of this analysis, ISPA's analysis, is to separate out B and H. So we could do that, yeah. Thanks. Alrighty. Well, with the sleep score of only 59, I feel quite chirpy about this, I've got to be honest. And I think, thank you very much. That's lovely. Thank you very much.